In this lesson, we are learning about the product rule and the quotient rule, which is where we are taking derivatives when we have two functions being multiplied together and then two functions being divided. So in this case, we cannot just take the derivatives of each and multiply them together. It's a little bit more complicated, that same thing. We can't just take the derivative of the top, derivative of the bottom. There is more to it. So here, to find the derivative of h prime is going to be, we will take the derivative of the first times the regular second plus the regular first times the derivative of the second. And then for the quotient rule, if we're dividing, to take the derivative, we will have the derivative of the first times the second minus the first times the derivative of the second, and then we're also dividing by the second squared. So these are two rules that we're going to practice in this video, but you will also need to memorize. Okay, so here we have our first example where we have 3x to the third times the natural log of x. So I want you to break this apart thinking of this as like the first part of the function, and we're multiplying by this second part of this function. So if we use that formula at the top, we can split them up into like f and g. So first we have to do f prime. So the derivative of f is 9x squared, and then times regular g. So we don't do anything to the ln x yet. We're just multiplying by ln x, plus regular f, which is 3x to the third, and then the derivative of g, which is derivative of ln x, is 1 over x. And then you always want to look to see if you can simplify anything. In this case, 9x squared and ln x can just stay the same, but this can simplify to 3x squared. So here we have this function is the derivative of this function. Okay, here's another example of a function where we can use the product rule. So we can separate this into f and g, and then we can also rewrite this as 3x negative 1 times sine of x. Okay, so taking the derivative of h, following the product rule, derivative of the first, so derivative of this is negative 3x to the power of negative 2 times regular g times sine x, and then plus the original here, 3 over x, and then times the derivative of the second, and the derivative of the second is cosine of x. There's not much we can do to simplify, but we could put this back as negative 3 sine x over x squared. And we could put this as 3 cosine of x over x. So there are two examples using the product rule. Okay, so now let's use the quotient rule. So here we have this rational function, which you can think of as a function being divided by another function. So the top we can consider f, the bottom we can think of as g. When you have rational functions like this, it's always good to look to see if you can factor cancel first, but we can't in this case, so we're going to use the quotient rule. So to find the derivative of h, we're going to start by the derivative of the top. So the derivative of the top, I'm going to use parentheses, is 2x plus 5, and then times the regular second, so times the bottom, x minus 4, and then subtract in quotient rule, and then it's the original f, so the top function, x squared plus 5x minus 2, times the derivative of the second. Well, the derivative of the bottom is just 1, and that's all over the bottom squared, so x minus 4 squared. All right, so with these, sometimes you can't simplify them much, but we can simplify this one. If I multiply those binomials, I'll get 2x squared, negative 8 and 5, so minus 3x minus 20, and then distribute this subtraction sign, so minus x squared minus 5x plus 2 all over x minus 4 squared. And now let's just combine like terms. We'll have x squared minus 8x minus 18 all over x minus 4 squared. And that is as much as that one will simplify. So this is the derivative of this original function up here. All right, let's practice the quotient rule again. So here we have the top function we'll call f, the bottom function we will call g. And to do the derivative, I'll start by the derivative of the top, which is just 3e to the x, and then times the regular bottom, which is 5 cosine of x, minus, okay, the original top, which is 3e to the x, and then the derivative of the bottom. The derivative of the bottom is negative 5 sine x all over the bottom squared. So that's 5 cosine of x squared. Okay, so let's simplify that a little bit. I have 15e to the x cosine of x. This will go to plus 15e to the x sine of x. And the bottom go to 25 cosine squared. And sometimes it is helpful if you see in the numerator that there is a greatest common factor between the terms. We could factor out that 15e to the x out in front so that you're left with cosine of x plus sine of x over 25 cosine squared. And really the only thing we can do from here is we can simplify that 15 over 25. So divide them both by 5. We'll have 3e to the x of cosine x plus sine x all over 5 cosine squared x. All right, for our last example, we're going to practice product rule and quotient rule after I just give you some information. So when x is 3, I'm going to give you that f of x will equal 5, f prime of x will equal negative 2, and g of x will equal negative 3, and g prime of x will equal 2. And we're going to figure out, well, first I'm going to give you a function. I'm going to say 4 f of x times g of x, and we're going to calculate h prime of 3. So the derivative of h at x equals 3. And then I'll have another function, let's say p of x is 2 f of x over g of x, and we will also calculate p prime at 3. Okay, so for the product rule, first I'm just going to do h prime of x. And you could think of this coefficient, you could just bring this coefficient out in front and then do product rule. So we're going to think f prime times g plus f times g prime. So to do the h prime of 3, we're going to have 4, and then f prime of 3 is negative 2, times regular g of 3 is negative 3, plus regular f at 3 is 5, and then g prime at 3 is 2. So to evaluate that, I've got 4, and then 6 plus 10, so 16 times 4 is 64. Okay, same idea with p of x. So p prime of x. Once again, that coefficient I could just bring out in front, and then I can do f prime times g minus f times g prime all over g squared. So to do p prime of 3, okay, so f prime at 3 is -2. Regular g at 3 is -3 minus f is 5. G prime is 2. All over regular g squared, -3 squared. Okay, so I will have 2 and then 6 minus 10 over 9, which will simplify to -8/9. So there is your video on taking derivatives using the product rule and the quotient rule. Good luck with your lesson.